Welcome to a new test and teardown video. This time it's another fantastic Nixie tube product. A Fairchild digital multimeter model 7000. Maybe the 7000 is referring to 7000 counts. I don't understand because I can see 5 in full digit tubes and a plus minus sign, something tube like that up here, right? So that one is special. So I don't know how many counts it can count. I just cleaned the front. Look how beautiful it is now. But I found some slime all over the front and it was really sticky and gross. And if I look in here as well, it looks like some of it is coming from the inside or is also just going inside. So instead of powering this up, I really want to open and clean it up and see if there's more or where is it coming from. And this is the rear panel. There isn't actually anything to say about this, but the power connector is a little bit special. This looks like a modification. Look at that. Somebody modified this because it was probably this weird old American power connector that is a pain to get a mating part for. And here we go, Fairchild Instrumentation. Fantastic. Yeah, let's open. Now we're inside, and the first thing that I note, there'll be some missing cards, both in here where it says counter or BCD counter or something down there. Let's get a little bit of light. BCD and counter. Something here is missing. And then we also got AC converter, ohms, I don't know. So we definitely got some cards missing, so that means some of the features from the front is probably not activated like voltage or ohms here. So we're going to have a little look what is going to happen. I've read about this on the internet. I googled a lot about this module to see what I could find. It is beautifully built. It really reminds me of HP equipment. This whole design style, the way that the cards are in here with the colors and everything here reminds me very much of HP. So it's definitely super good quality build. Look at that. Some ICs was replaced up here. I like the idea with the transformer, capacitors, power supply. All that is, of course, far away from all the high impedance input stuff. This one is a high impedance meter. Let's flip it around and look at the back, or the bottom, of course. And again, it smells of HP. Look at all the cables, the shielded cables. And that is the logo modification for input mains. It is really beautiful. Definitely a collector's item. I like that. There's a leakage shield around here and all that. I only see a little bit of that slime I was talking about here in this slot. Can you see what I'm talking about? It is shining. Yeah, you can see it down here. That is not too good. But it looks like it's not coming from inside this instrument, and that was my biggest concern. It's also visible down there, right? Some kind of gross stuff. This is probably going all the way down as well. Nasty. So I pulled out the display unit. They called it counter. And if you look careful, you can see 4 sets of counter driver chips. So that will be for the 4 tubes to the right. And also if we see the populated tracks for the Nixies, that means the 4 tubes to the right, they can probably do all the different counts, and that one can probably only do 0 and 1, maybe 2, but it can't do all of them. So that is how I expect this will work. Really nice and big, those tubes. And look at the indication here, how this is done with neon bulbs. It's absolutely beautiful. And yes, it was serviced. The layout technique here is clearly manual layout. You can see the way that the tracks bend around here, different bending angles, then in and out, and I do PCB layouts for a living, so I almost get wet eyes from seeing stuff like this, because it must have been a very, very different world. I see some, I'll try and see if I can decipher what it says here. Sheridan. So that's a name. And we got some stickers here. The stickers are, yeah. Oh, by the way, I mentioned this kind of weird slime. See? On the left side of the aluminium here, it's, oh, here you can see it really, really clearly, right? So this unit is full of some sort of a undefined slime. Oh no. I'll see if I can fix this. But it's not looking like it's coming from this instrument. At least that is my theory so far. Cleaning up this slime from the inside. And I don't know if you can see this. Some really weird, sticky slime-o. What the heck is that? Just cleaning up everything here is, of course, what we need to do. So that is a logic board, whatever that means. And the other one here is called auto range. Very, very beautiful layout. Big, fat tracks and all that. Oh, look at that. First, second, fourth, all sorts of cool things. I really like the layout and the order of doing PCBs like that. Yeah, I wanted to show you the contacts down here. See, they're really nasty, dirty. So this is something I need to clean. It's also the same here on the top. Next module is called AC Converter. And what I think we see here is a dual slope conversion. We see all the capacitors and all that kind of stuff. There's gotta be something with that. Look at all those field effect transistors, a few op amps or comparators and stuff like that. Yeah. Don't you like the text around the connectors? so it's easier to figure out what is going on. Love it. Yeah, it went through some service in its life. The next one is called input amplifier. It's completely sealed behind this little shield here. Ooh. Beautiful design. It's also got a little relay there and all that kind of stuff. And if you look at the contacts, we got some green goop on the contacts, and I'm telling you, it was difficult to pull this up. So all this green goop turned itself into glue, so it was really, really difficult to pull this up. Somebody's using some really bad quality cleaning, but not all people know how to clean stuff. Oh yeah, and the next DC attenuator. Again, a lot of relays, different sizes as well. KX and K1. Beautiful implementation. And look at that, not even PCB material here is not good enough. So what they're doing is they're adding Teflon. Or is this just to hold this glass, or it looks a little bit like that, right? They're definitely trying to handle leak here. 9.85 mega ohm 10K. Ooh, we're dealing with some high impedance goody stuff here. Yes, Teflon inserts, love it. And the last module is the power supply. They called it the Fairchild regulator. Don't you just love it with the colored test connectors here at the top for different voltages and stuff? That is just lovely. The 4 blue capacitors here, they're all 64 volts, 64 microfarad, and they look like they are up for replacement. See that one here. They have seen better days. This is probably tiny little acid leak that cracked the plastic, and you see it as well here. So I really recommend changing those at least. But first we'll see what happens. Yeah, that is a little leaky. I really like the layouts. It's absolutely beautiful. And if you see down here as well, all the diodes there are aligned. So beautiful. Jumper board. That's probably because something else is not mounted. So, like always, I promised you to be here when I power this up. Do you hear this? Oh, that transformer is just saying, oi, 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 it sounds like it's... Oh, do you hear this? It's because of there's like some mechanical amplification here. Stuff can move, but it seems like it's alive, right? This is voltage DC, voltage AC. Haha, milliamps, ohm. There's another one called test. What are we testing? Ah, this is the internal reference. How funny is that? So that should of course be 10.00, right? Let me find some voltage and test with. I really did not expect this to happen. What the? So this is the full range is 1 volt, or it's the 1 volt range, and I don't know what you call this. Is this just high quality or what? How is this really possible? It is, I mean, this is 50 years old, this instrument, and it is still reading this accurate. Holy camole. Let's try the next. I actually wanted to see what happens. There is an overload here, and this is 1 volt. How about I crank it up? Go over here, and then let's go to fine, and then give it 1.9. Okay, so that also works. We got a little bit of cathode poisoning here at the 9, but we can still read what is going on, right? But oh, see, now it's blinking, but it's actually reading the 1.9, but it is complaining. So what if we go down to 1 point? Okay, it's still complaining. Isn't that a little bit amazing? It's still, okay, here we go. 1 point, okay, then it complains. So 1.2 is all right. There's a little bit of filter here. We could also make that faster. So 1.2 is okay, and it actually shows a lot more, even it is complaining. And volt DC here is all right. Oh wow, I gotta go and play a little bit more with this, and then I will probably come back. It is the same in the 10 volt range, by the way. So 11 is okay, but 12 is not okay. So that is how this thing works. And again, it's only 1 count on the last digit, and I just turned it on right. So if we wait an hour, it's probably gonna be spot on or something like that. Let's try a little bit with volt RMS. This is by the way 1 kilohertz, 1 volt RMS, as you see up here. This is what I got in, and so the time integration, or the time filter in this the AC mode is really slow. Or is it actually working? See what's going on here? So that is probably the missing module, or is it just going down and then back up? I don't know. It looks like it's probably lotto numbers we're going to see here. I don't know. My patience is about over. Maybe it's something to do with the frequency, right? So let's just go for 100 hertz and see if there's a difference. It still goes up. Oh, that's crap. Maybe it has something to do with that. 1 volt RMS. I think it has something to do with this module that is not in there, so that gotta be it. Okay, so something here is definitely not working. Milliamps. Nope, no luck with milliamps. And if I short here, I get my 100 milliamps up here, so disconnect. So there's probably a fuse in here somewhere. Let's see if we can find that. But then I will play with the ohm first. So there's definitely something with the resistance as well. So maybe that is another module that is missing or something like that. But it seems to be reacting. See? So now it's shorted and now it's open. But this is a 1 mega ohm resistor. I don't understand this exactly. So now we are in 10 mega ohm. Ticky. I went through all sorts of different resistors and whatnot. It's also not working in resistance. Maybe it has something to do with the same fuse that is broken or something like that. Let me have a look. It is me, who's real bad at remember stuff. See? The card for ohms is missing and the card for AC is also missing. So that explains those two ranges that are missing. But it doesn't explain why milliamps is not working. And I've been searching around inside this unit and there are no fuses other than the mains fuse. So it gotta be something, some of those range relays or something like that is just not working. So that is my take on that.